Good evening, everybody. This is a live extreme weather briefing as we've just had an EF4 tornado confirmed once again in southern Mississippi. This is the third EF4 in a week in the same region here in southern Mississippi. Last week, Sunday, Easter Sunday, there were two EF4 tornadoes across this region. One that was over 60 miles long. Both of those EF4s were produced by the lead storm. There was also an EF3 tornado with an over 60-mile long path. And this tornado last night was given an EF4 rating as well. It was a lower end EF4, and this tornado was on the ground for over 54 miles. So once again, yet another very long track tornado. The damage video, the drone video you see underneath it, that is from Highway 35 just to the south of the Columbia area, and you can see those trees that are snapped very close to the ground. That's a telltale sign that this was definitely a strong tornado. Most of those trees were oriented from the west to the east direction as they were knocked down, and that's because this tornado is moving over 50 miles an hour, 50 to 55 miles an hour, so it is very difficult to get those trees lying down from the east to west direction with a tornado that's moving this fast. But this was not the location of where the EF4 rating, or for the reason why the EF4 rating was given. Pulling up the damage survey just a little bit greater, blowing it up there. I can show you where that EF4 damage indicator was, and it was one house out here just in the southwest corner of Marion County that was that gave this tornado an EF4 rating, and it was a house with just a slab foundation that was left behind, and a little bit of debris was piled up in the corner of that foundation. The debris was not thrown very long distance. That's why it wasn't given a higher rating or an EF5 tornado. Those anchor bolts were a little bit bent, so this home was anchored to the foundation and was completely swept off that foundation, but some of the debris was left in the corner of that foundation instead of being swept completely clean. And there were some trees as well in the surrounding area that did have some debarking that definitely supported the robustness of this rating. You can see a couple EF3 indicators there as well. This is Highway 35 right here just to the south of the Columbia area. That's where I just showed you that drone footage. Those are some EF2 indicators there, but the tornado reached peak intensity just to the southwest of Highway 35 there, and it continued to the east of the river, producing some more EF2. And this tornado was on the ground for a very long time, even passing into the southeastern side of the Hattiesburg area. It did cross Interstate 59 as well, just to the north of Purvis, and some EF1 indicators toward the end of its path. But definitely a very long track tornado that was on the ground for over an hour and 9 minutes officially, with estimated peak winds at 170 miles an hour. And very sadly, down near Sandy Hook, down at a mobile home just to the south of Columbia, there was a fatality. There was a mobile home that was completely obliterated down there by this tornado, and it was over a mile wide, 1.25 miles there, so a very large, wide tornado as well. And we had the drone in the air on this tornado. Here you can see the drone footage to the south side of the Tylertown area, and this was just west of where the EF4 tornado touched down. This was as it was approaching the road just on the south side of the Tylertown area, and this had a hook that was definitely coming around the south side. You can see a very, very large wall cloud, and that dark area on the right side of the image, that's the lowering. You can see some inflow as well feeding into this. There you can see that video. This is the drone video, and that dark area off to the right is the circulation that eventually became the long track EF4 tornado, but really a huge wall cloud there. And this drone was definitely a vital tool to be able to see the structure of the storm as it was approaching, because there were a ton of trees all around there. Incredible positively charged lightning strikes as well. You can see those very smooth cloud to ground strikes. Very frequent, quick, powerful strikes. That's how you can tell these are positively charged. And I've seen this happen quite a bit, where an uptick in the positively charged lightning. Make sure I don't have the audio going on this thing. Precedes the tornado, and tornado genesis happened about 10 minutes after this drone footage as it was approaching. And here is that capture that I'm going to use to break down the structure of this storm. There were actually a couple different circulations as this was approaching me. You kind of had an elongated north-south oriented mesocyclone, but it was a very intense mesocyclone as well. Here, you definitely had a little bit of some curvature with a smaller scale RFD gust front there, a little bit of a circulation at the apex of that RFD. But you had a very larger scale RFD gust front that was bulging out right here ahead of that very large circulation. This is the dark area that was at the apex of the RFD gust front right here that is bulging out toward the camera. And then you have the inflow feeding in right along the forward flank gust front into that circulation. So it's this circulation that becomes the primary one here that becomes eventually that EF4 tornado. And this RFD gust front bulges out, occludes this circulation. And I'm going to show you that with the on foot or with the ground intercept video approaching that tornado. You'll be able to clearly see the RFD cut wrapping around the developing tornado cyclone. I was worried that this circulation was going to become dominant, in which case I would have to drop south to get a closer view of that tornado, but it ended up being this circulation, which was coming directly toward me at the time of this image. But you can certainly see the concavity or the bulging out of this smaller scale RFD, and you can see those striations right along the RFD gust front, and you can certainly make out the flow and the general structure of this HP supercell as it was approaching me. So here is some radar imagery as I was approaching the storm. And a key feature on this one is that outflow boundary. There you can see just to the south of my GPS position. My GPS position is indicated by the blue circle right here. And I was trying to get into position for the target storm. This was the furthest south storm right here that became the dominant tornado producer. You can tell that the wind shear isn't quite perfect for this storm to really wrap up. The hook-like appendage even has a little bit of some anticyclonic curvature, but I could see on radar velocity that this storm was beginning to develop inflow at the higher radar tilts especially. It had a very large inflow swath on the southeast side of it. I could tell that this storm was intensifying. It was about to go nuts. The echo tops were up to 55,000 feet, so that was the strength of the updraft was very intense. Hail size was indicated at greater than 2 inches in diameter, although it was basically dominated by warm rain processes, almost like a developing hurricane there just to the southwest. I knew that I was in perfect position to intercept this. But the most important feature on this radar image here is this outflow boundary. You can clearly see it right there on radar reflectivity. See that little line? And to the south of that, temperatures were in the upper 70s to near 80. To the north of that, the temperatures were in the low to mid 60s at best. And that outflow boundary was reinforced by some storms that tried to get going to the southeast of to the east of the Jackson area, and then a squall line came through, and that caused this outflow boundary to sag down to the south, which caused all of these storms to basically have zero tornado threat because they were moving into this stable air reinforced by that earlier convection along the I-20 corridor. This storm tried to wrap up and latch on to the boundary, had a little bit of rotation. This one here also tried, but really this southern storm was the only one that had an opportunity to mature in the open warm sector. A lot of instability down here, and then latch on to this outflow boundary, which likely weakened the surface winds, even backed them just a little bit, and caused that photograph to become extremely favorable for strong tornadoes as that storm tracked across far southern Mississippi there. This was the RAP analysis the morning of, and you can see this blob of instability down at vecting northeastward with a 40 to 50 knot low-level jet. This was the warm front that was reinforced throughout the day by several different waves of convection that attempted to develop. There was a storm just to the east of Jackson that tried to latch onto that warm front and would have became tornadic if it had just enough low-level buoyancy, but there was too much stable air along that warm front. And usually when you look at the models the morning of and you see a wavy pattern like this well east of the wave, you know that there's likely several attempts at storms that develop, and during those concave areas, that's where the stable air is just a little bit deeper, and so those storms will develop, cross the warm front, move into that stable air, and then peter out just a little bit. And you really need the elevated mix layer to come in from the southwest, and that's what was steepening these lapse rates as that drier air came in at the mid-levels of the atmosphere, causing that cape to explode. 2,000 to 3,000 cape here, a blob from southeastern Louisiana into southwestern Mississippi. Surface winds out of the south-southwest, but they're weak. So when you have a 40 to 50 knot southwesterly low-level jet over top of that, that creates some pretty extreme wind shear. And that's why the target area the night before we had was across southern Mississippi into southern Alabama, basically along that warm front, but ahead of that 700 millibar speed max as well. That was where the main show was going to begin with this one. And here is some more early radar as I was waiting for this storm in the Tylertown area. And I could really tell that this storm was ramping up because of the concavity here to the reflectivity and how smooth it looks, or laminar. And you can see this large appendage there, and it was beginning to develop that larger scale cyclonic curvature throughout. So I knew that this is developing a deep mesocyclone, a large-scale mesocyclone. The evolution of this storm actually reminded me a lot of the Linwood, Kansas EF4 tornado last May 28th, 2019. It was an HP storm that really began to develop a robust inflow region in the southeastern quadrant. Had a very large mesocyclone as well, just large in size, so almost larger in the mesoscale spectrum than some of the smaller supercells that produce compact, strong tornadoes. But these large systems like this are capable of producing those really long track, large tornadoes. And what told me that this storm was really about to go nuts was this large inflow appendage too. And that develops a large region of potential cyclonic vorticity there that can easily tighten up into the compact inflow region. And you remember that drone footage, that darker area that was right at the interface of that rear flank downdraft and the forward flank gust front. That's the area that you want to watch for that circulation to form. And as the storm approached me, here you can see that updraft base that I was telling you about, that blue line, that's that basically that's the bulging out rear flank downdraft as that is lifting off to the northeast. That circulation, let's see if I can find this image and annotate it. But that radar image there was when I had the drone in the air and looking off to the west. You can clearly see, there we go. So here you can see that cyclonic curvature as well, a very smooth reflectivity gradient there as well. This is where I launched the drone just to the south of the Tylertown area. This tornado ended up touching down the EF4 tornado off to the southeast of Tylertown. I wouldn't be surprised though if there were some weak damage indicators in between these two locations. And here you can see the bulging out RFD gust front I was telling you about in that drone video. I was looking off to the southwest. Here you can see the forward flank gust front, and that darker area right here, the interface between those two gust fronts, that's what I was looking at for the developing tornado. This eventually tracked right toward my location, and now I'm going to show you that intercept video. Right here, this is the intercept video that I just had the audio over top, and that's looking north at the cut. There you can clearly see that clear slot. That's the developing tornado cyclone right there on the southwestern side of Tylertown. I thought that was actually a tornado, probably a weak tornado. The winds were definitely intense in that mass, but this is what became the EF4 tornado just to the southeast of the Tylertown area. Now I'm going to break down the still picture right here, and this is a clear slot that I'm telling you about. So you get big westerlies just on the south side of it. The bulging RFD is over my head right now, the RFD gust front, but you have these westerly winds cutting through on the south side of that tornado cyclone. You have inflow on the north side of this tornado cyclone, and so I was looking north, seeing rapid west to east motion right there. You can see how low the cloud bases are, basically a ground scrubber tornado cyclone, if not already a tornado. This is becoming the back edge of what would become a wedge tornado as it was moving off to the east. So I knew that this was a dangerous storm. I knew that it was going through the motions. This was the tornado cyclone. You could basically call it a tornado. If we had the Dominator 3 out in the field, we'd be shooting rockets into this thing. The sensors likely would have been carried well in excess of 50 miles. Debris was getting lofted up to 17,000 feet by radar just to the southeast of Tylertown once this thing initiated. But this is looking to the north at that circulation, and I told you that I always monitor the wind direction when I'm chasing at night. So once that RFD gust front went by, winds shifted out of the west. That's when I was looking off to the north at this developing tornado cyclone. Large circulation there, big westerlies coming in, storm relative easterlies on the north side, and this is what became the 54.2 mile long EF4 tornado. Here's some more radar imagery as well, showing that supercell as it was approaching the Sandy Hook area, which is where I was flying the drone doing the damage survey. Look at the cyclonic curvature on that hook-like appendage now. And this is that massive inflow region that I was telling you about that often happens before these strong to violent tornadoes are produced. When you have a huge inflow region like that, you know that this circulation is becoming dominant or is already dominating. These are the northerlies on the backside. Debris here. Correlation coefficient drop, completely surrounded by much higher values, and that was lofted up to about 15,000 feet. This is interstate. This is a Highway 35 right there as this large mile-wide wedge was approaching that north-south road. At this time, I was up here on Highway 98 trying to keep pace with this storm. We were basically 4 to 5 miles, maybe 5 to 10 miles just to the northwest side of it, the whole way up to Hattiesburg. And my plan was to drop south. Here you can see almost a bounded weak echo region on the lowest tilt. You go higher up and you'd have a completely bounded weak echo region with this storm. But certainly a textbook. Let's go back to the damage survey map again. Well, here you can see that drone footage. This is near Sandy Hook, flying west from Highway 35. You can see that grove of trees just to the west that were snapped off just above the ground. Some destroyed homes there. And it was west of this location a ways where that slabbed home was located. There you can see some trees snapped off pretty close to the base as well. And here you can see that grove of trees snapped off just above the ground. If the trees are debarked, then you can consider going an EF4 tornado. I don't see any debarking. That's why I was trying to get low into this grove of trees here. And it really was that outflow boundary that weakened those winds just enough to elongate the hodograph. And again, here's that drone footage looking southwest at that bulging out RFD gust front. You can see the bulge. You can almost see those striations. And then there's that lowering right at the interface of the rear flank downdraft and the forward flank gust front. And my plan is to target the northern Texas Panhandle tomorrow. That's where I'm heading. I've repositioned well to the west, and I do expect supercell storms to erupt in the central northern Texas Panhandle, eventually moving into western Oklahoma. And I see that I didn't include the hashtag supporters thing on there. I did a stream just a little bit ago that was failed, but if you guys have some deeper questions, please consider joining the Facebook supporter community. I'm able to break down the questions a lot easier. I do briefings every single day on there. Meteorological breakdowns, live streams are all made possible by our Facebook supporter community. But this was last night, long track EF4 tornado, and I'll be back on supercell storms tomorrow in the northern Texas Panhandle. I'll be streaming live. And then I'm going to be targeting the Dallas-Fort Worth area on Wednesday afternoon and evening. And then it looks like areas in the southeast, again, Georgia, southern Alabama, probably Georgia and the Carolina Piedmont could be impacted on Thursday. So thank you guys so much for joining me this evening. I'm going to get some sleep, hitting the road first thing tomorrow morning, heading up to the Texas Panhandle, and we'll have much more clear-cut storm structure than what we've seen in Dixie Alley here recently. A lot of low visibility storms. Sometimes it can be hard to see with those trees. But still, the storms have to follow the laws of physics, and that's what we try to break down here. So have a good evening, and we'll see you tomorrow when I fire up the live stream.